Okay, so let me record a CCW video on week 5, assignment 1 for November of 2021. What I'll do here is I'll show you how to discover your drive. I've checked previously and I know that they're available, so I'm going to click on Discover. And I'm going to click on this driver. And I only have 2 objects on the network. I have a PLC and I have a drive. So 104 is my controller and 230 is my drive. I'll click on 230. Okay, so what I've got here is I've got the drive. I'm connected to it. What I'd like to do is check the parameters. I'm going to show non-default parameters. So these are things that I have changed or have been changed. What I'm looking at here is that it has an IP address set inside. Got an IP mask, subnet mask on there as well. No other parameters have been set, so it's in good shape. What I'm trying to do is avoid clicking on the wizard to reset the drive, because it probably is going to wipe out the IP address and I'll have to put that back in. So I'm just going to go straight to the parameter list and show all the parameters. Okay, so assignment number 1 for week 5, it says the start sources are set to default. Well, I know they are, but I'm going to check just to be on the safe side. So the start sources, well, there's a lot of non-default settings in here. These are all non-defaults. So let me go back to the main list here. So the start source 1 default is the keypad. Okay, so I'm going to reset that. Notice it's right here as well. So if you ever forget which one it is, it's right here. Okay, so drive pot will be the default. 1, 2 is okay. 3 should be Ethernet. Okay, so I'm back to default settings here. Acceleration time, I'm looking ahead, it's supposed to be 15, so this is already set up for this assignment. 15 seconds, 15, 32, it should be 27 hertz at the bottom end, and 63 at the top end. Okay. Reverse operation enabled, that's parameter 544. Okay, reverse enabled. So we want to make sure that that's selected as well. That is a default setting as well. The only thing that's not a default is it says use terminal block to select start source number 3. Okay. So what we're going to do there is we're going to use input number 7, because the default for 7 is speed and start source 2, but we want speed and start source number 3 as my setting. So what that means is if I make pin number 7 on the terminal block positive 24 volts, it's going to start from source number 3. And if we scroll back up, source number 3 is the Ethernet IP adapter, and that's what we want. So by doing it this way, what that allows me to do is I can just, in this case, put a jumper to force it to look at source 3, but I could also put a selector switch and toggle between source 1 and source 3. If I was going to do that, I probably would try to reassign source 1 as the terminal block, because there's a safety issue there. If I'm using the keypad and the drive pot to start and control the drive, that means that I'm opening the enclosure that the drives are mounted in, and I'm exposing myself to the high voltage that's present there. So from a practical standpoint, I don't really want to use the keypad unless I'm able to disconnect it and relocate it. but in this case, that's not the case. So just a side note, right? Not to get too far off the track. So these settings are correct here. Everything looks good. The nice thing about the CCW is that if I'm live online with the drive and I'm making changes, those changes are already in the drive. So I don't have to do anything else at this point. What I might do is just save the project as, and let's give it a name like 2331, week 5, assignment 1. So what that does is it gives me a copy of the project settings. So if, worst case, something happens to the drive, I can open the project and download those settings back into the drive. Okay, so that's all I can do on the drive side. Next thing I'll do is start up the ladder logic and show you how to incorporate the drive into your project and maybe a little bit of the programming behind that as well. Okay, so here's the PLC side of the drives week 5 assignment 1 project. This is not officially part of the drives class, but since drives and PLCs go together, it gives us something practical to look at from the PLC side. So the first thing I'll do is I'll look down here at the Ethernet listings, and I need to bring in the drive so that it's part of this project. So what I'll do is I'm going to be offline. I'm going to right-click, add a new module. I will type in 525, and I know that my PowerFlex drive is this one, the embedded Ethernet version. So I'll click on that and say create that. I'm going to expand this window a little bit. It would like for me to give the drive a name, so I'm going to call it drive week 5 assignment 1. The IP address, I'm going to give it 192.168.1.23. I know that because I looked on RS Links and I saw the IP address of the drive. Also through RS Links, I know that the firmware version in the drive is 6.001. If I select the wrong firmware version, I'll get a fault over here on the IO fault indicator, and I'll get a message at the bottom. And it'll tell me that it's got a problem with the major revision number of the firmware. So just to avoid that problem, I'll set it up correctly from the start. Okay. So let's click on OK there. And I'm going to create that. I'll close that window. So what I've got now is a PowerFlex module added to the project. I've got a couple of tags that were created for me in the controller tag listing for the drive. Inputs are actually outputs from the drive, but they're inputs to the controller. Okay, so this is drive status information, including the output frequency of the drive. Notice the different data types. I've got some integer data types and some Boolean values. These are true false. These are bits. These are numbers here. Okay. If I look at the output tag listing, output meaning these are outputs from the PLC to the drive. These are actually the control bits: stop, start, jog, forward, reverse, acceleration, select acceleration rate 1, 2. So these are just control bits, right? Command frequency is the speed, the frequency that you'd like the drive to operate at. It's times 100. So 60 is 6,000. So it looks good. So far, so good. So let's download this project setup to the PLC so that it can start to work with it. So I'll click on the Who Active button. I'll go down here to my network, and I'll wait. 104 should come on. There it is. And I'll download to it. Okay, so far so good. I have no errors, no warnings. Looks good. Everything's going correctly. Run mode, yes. Okay. So if I go to monitor tags here, I will start to see that there's some data there. Okay. The drive is saying that it's not ready. It's got a fault indication on it. So see how it's faulted right here. So what happens when you download to it, you lose communications with the drive when you download to the PLC in the stop mode. So it's okay, it's no problem. I can actually fix that from here, I think. If I set this to be a 1, let's go back and look at the faults. Yeah, it's cleared off, and the red light stopped blinking over there. So now the drive is ready. Okay, it's ready to do something. So let's try and write a program to make it do something. So for this project, let's see what it says. Stop is input 0, start is 1, reverse is 2. Okay, so I have some switches wired to the PLC. I have a start-stop. I don't have a reverse switch. So what I'm going to do is I'm going to use a base tag for that. I'm going to call it rev. Okay. And I'm going to make a new rev. And over here, I'm not sure that worked. I guess it did. Over here, I'm going to select the output bit called reverse. This one. So if the rev switch is on, I'll go in reverse. So I'm going to accept those changes. Also, if the reverse switch is not on, I'm going to go forward. So I'm going to change this up to a examine off, and I'm going to copy this down here and then just modify it. I have to do this because I have to go forward or reverse. So right now I'm going to go forward. If I toggle this contact, I'll be going reverse. So normally that would be a real switch, but since I don't have a switch, I'll just toggle that. Okay. So I'm going to add some blank lines up here. I'm going to leave this down at the bottom down here. Let's accept those changes. Yeah, it's not going to let me do that. Well, let's clean this up a little bit. Now I'll accept the changes. Okay. Let's add some blank lines here. Okay. So start stop, that's important. So let's do a stop and a start. This can be an internal coil called run. So let's build the structure and then I'll go ahead and populate it. So this is the stop switch. That is a local input 0. Okay, nothing new there. This is the start. I realize I cut a corner there, so let me get back to that. Give me a second here. That's an alias for local input 1. Okay. Change this to STOP, stop. What I did there was I actually pulled down the actual physical connection point instead of making a tag called stop. And we don't normally do that, so I have to back up and fix my problem there. Input 0. So there's stop, input 0, start, input 1. This can be the run coil. Run coil. It's a base tag. And I'll just copy that. Okay. So I press start, get the run, hit stop, I lose the run. So right here, I'm going to put the run coil. I'm going to put a close contact, which is the active bit from the drive. Okay. So what this does is it will apply a start signal to the drive. Until the drive is active. So it's kind of a momentary start. The start signal from the PLC has to transition from off to on. So there's really no point in keeping it on. It's not level sensitive. So you start it and then you stop it. So for the stop function, what I'll do is put a not run coil, and I'll put a stop. So I'm going to select that and edit to go with that. So start, stop, run, not active. That's the start signal. Not run is a stop. And I'll hold the stop off because there's no problem with doing that. I don't have to, but I'd like to just hold it off. Okay. So I've got reverse in there. The only thing I don't have a picture of here in my notes is I think I had planned like a series of speed ramp ups, right, from slow to fast. So what I'd like to do right here, let me see if I can add this in there. If we're not running, I'd like to move a 0 into the drive frequency, which is going to be a frequency command. So that will force a 0 into the drive to make it actually stop. So not only is it going to stop, but it's going to run the speed down to 0. It seems like the same thing, but it's not, because the frequency command number, unless you reset it to 0, it will stay at wherever it was before. So we have to be sure to actually push that down to 0, so that it will start up in an operational condition. I'm a little low on power there. Okay. All right, so let's do maybe one timer, because it'd be nice to see one timer go. So we're going to do a run coil here, and we'll have a timer, like a 5-second timer. TR1. So after 5 seconds, we'll ramp it up to about like 4,500 hertz. So I'll put a open contact here, TR1.done. Do a move instruction. I'm just going to copy this move, save a little bit of time here. 4,500 into the frequency command. So how about as soon as we go to run, we'll push 2,500 to get it moving. So let me see if I can squeeze a line in here. I'm going to copy this. This. Put like 2,500 in there. Okay. And we're going to do that until TR1 is done. So I'm going to copy that up there. So I'm going to push 2,500 to get it started. The timer is running. So after TR1 is done, I'm going to go up to 4,500. And I think I'll just stop with that. Okay, so let's accept those changes. And I'll walk my way back through it to kind of clarify. Just look at it to make sure it makes sense to me. Okay, so start, stop. We press start. We get the run coil. As soon as we do that, we push a 2,500 into the command frequency. The drive will start. So yeah, it's not faulted. Start. So you go to 25 hertz. After 5 seconds, we go up to 45 hertz, and we stay there. If I flip on the reverse switch, it will slow down to 0 and go back the other way. Okay. So the drive is connected and there's no faults on it, so let's give it a try. Okay, it did not start, so I'm looking now to see what could be wrong with it. So let's look at the tags here. I'm going forward and then start. So let's do this. Let's toggle the start stop. Okay, I'm not seeing anything there. It's ready. I'll put the frequency at 0. Let's see if I can toggle it. Not getting anything from it. I'm in run mode. Let's go back to the. Let's look at the drive for a second here. I'm not getting any errors, so that's good news. The main program looks okay, but I see a problem. Let's try. Let's just watch it and see what's going on. It really should be running. So it's a little bit of a mystery. So let's try to solve this problem. Close connected components, and I'm going to double click on the drive. The drive says that it's running. Got all the cables connected. So let's see what comes up here. This is very strange, but it's okay. We'll try to work through it here. I know what I did. I got busy talking, and I forgot to connect the jumper to cause it to look for the Ethernet inputs. So that was number 7. So that's a common problem for me as I type and talk at the same time. I look for a little screwdriver. I'm going to pause this video for just a second and see if I can add that jumper to it. Okay, well, couldn't pause the video, but I think I've got the problem solved. Let's look at it again. I'm going to stop it. Start it. It's working now. I'm going to go back and look at the output frequency. It's working. Okay. So that's an interesting problem. Let me unplug that wire for just a moment. Stop it. And look at this. It's ramping down. But what I'd like to do is figure out if there's a way for me to have indicated that there was something wrong with it. And I'm sure that there is. If I look at the active bit here, let's go back and try to start it. I pulled that wire off. So if I press the start button, notice how the active bit never turns on. Okay. So I think that I'm triggering the drive, but it's never going active. So let's look at this a minute here. It's ready, but it's not active. So let's add a line here. I'm going to pull down the active. And this is going to say drive is active. So I'm going to try to start it again. And of course it won't start. Let me plug that wire back in. Try it again here. There it goes. So that's a mistake on my part. I was too busy trying to get this set up without connecting a wire. But it works fine. So the concept is the same. Same as like with motor controls, start-stop, seal-in circuit. This gives me a momentary pulse. When it becomes active, it stops this coil from operating. This is just an indicator for me to remind myself that it actually is working. This could go to a green light. You could have an output turn on when the drive is active. Run coil forces a 0 when it's off. Timer here, we get a few seconds of 25 hertz, then we get 45 hertz. And it stays there until I press the stop button. And it ramps down to 0 at that point. Okay, so it worked okay, except for that wire that I left off. Seems like it's always one wire. So that's how you do it. The process, the biggest part of the process is pulling the drive into the project. From that point, it's just ladder logic.